For generations our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. Heat, heat, heat. In our solar system, gravity is destiny. It is what sets one world apart from another and puts different planets on vastly different tracks. This fundamental truth begins with the sun, a giant blazing ball of hydrogen gas. The sun keeps shining because the force of gravity squeezes the matter in its core together until it is hot enough to generate nuclear reactions. Gravity also built the planets from the matter that swirled around the infant sun. In the beginning, most of that matter was in a gaseous state, but near the sun, it was too hot for gravity to hold on to the gas. So, the planets that formed in the inner solar system were small and rocky. Farther away, it was a different story. In the outer reaches of the solar system, it was always cold enough for gas molecules to stick together and form ice. Billions of years ago, that ice gathered into bigger and bigger chunks until gravity took over, pulling in vast quantities of material, and setting the stage for planet making on a giant scale. Here's what happens when you get enough gas together to make a planet. Jupiter is the colossus of our solar system. Beneath its swirling clouds there's enough room to fit 1,000 Earths. Jupiter is big, too big to be a solid body. Instead, its interior is mostly liquid hydrogen, the lightest element in the universe. This hydrogen ocean is well hidden beneath Jupiter's turbulent clouds. Because Jupiter is liquid, it can spin on its axis at high speed, much faster than Earth. One day on this mammoth world lasts only 10½ hours. This fast spin generates high-speed winds in Jupiter's atmosphere, giving the planet a striped appearance. Somehow Jupiter's rotation also powers the Great Red Spot, a giant swirling storm larger than the entire Earth that has been raging as long as astronomers have had telescopes to watch. The spot has a deep structure that penetrates many tens of kilometers like an open window into Jupiter's atmosphere. Jupiter's visible cloud tops are made of ammonia, but scientists have not yet discovered what chemical pigment gives the Great Red Spot its distinctive color. Other storms come and go on Jupiter. This unique view made of many separate images shows the atmosphere of Jupiter as it would appear from somewhere above its south pole. Over time, the spots move and sometimes collide like giant ships on a stormy sea. But none have lasted as long as the Great Red Spot. The poles of Jupiter are also where we find intense aurora caused by solar particles trapped in Jupiter's powerful magnetic field. Like giant-sized versions of the northern lights on Earth, they glow brightly in ultraviolet light. Jupiter is bigger than all of the other planets combined, and more dynamic. And for this reason, it is mesmerizing to watch. But there is another place in the solar system where gravity has outdone itself in creating a spectacle of stunning and otherworldly beauty. Centuries ago, astronomers were enchanted by the discovery that Saturn, the most distant planet that was known to the ancients, is encircled by what appears to be a set of narrowly divided rings. And as telescopes grew in power, so did the grace and grandeur of Saturn's rings. As these views from the Hubble Space Telescope reveal, the rings may start out at a wide angle but eventually narrow to a thin plane, almost disappearing when the planet's equator lines up with Earth. It is because of observations like this that we know the rings of Saturn cannot be as solid as they look. A solid ring would quickly become unstable and collide with the planet. Instead, the rings must be made of trillions of icy particles ranging in size from snowflakes to giant boulders, all guided by the gravity of Saturn and its moons. In 2004, scientists were given their best chance to learn the secrets of Saturn's rings when the Cassini spacecraft made a close pass of the rings before putting itself in orbit around the planet. As Cassini raced by, scientists trained its cameras across the ring plane, capturing one snapshot after another of the detailed patterns within the rings. These wave-like ripples are caused by the gravity of Saturn's many moons, which act on the ring particles to create shifting patterns of density while opening up gaps which are kept free of material. In some cases, these gaps are patrolled by small moons, which shift the particles with their gravity and give the rings their sharply sculpted boundaries. Here, a newly discovered moon only 7 kilometers across is spotted making waves in the rings on either side of a narrow gap. Cassini has also studied the elaborate pattern of kinks in Saturn's narrow F ring. These kinks are created by the gravity of two moons, Pandora and Prometheus, that shepherd the ring particles and keep them on their narrow track. Among the strangest phenomena Cassini has witnessed in Saturn's rings are these fleeting dark spokes that seem to race around the rings much faster than the ring particles themselves. They are made of fine grains of dust, probably electrically charged and swept up in the motion of Saturn's magnetic field. Saturn is alive with electromagnetic energy, and like Jupiter, its poles are ringed with bright dancing aurora. But in other respects, Saturn's polar regions look very different than Jupiter's. Here, Cassini gives us our best view yet of a strange hexagon centered on the planet's south pole. The hexagon is made of clouds and shaped by fierce winds, but the origin of its unique geometry remains a mystery. Cassini has revealed Saturn so beautifully that it is now one of the best imaged planets in our solar system, despite its great distance from Earth. Yet with each new image, Saturn continues to surprise and amaze us. This remarkable image shows us Saturn eclipsing the Sun, a view we cannot see from Earth. It is a heavenly image, even a poetic one, made even more touching by one other tiny detail. Buried in the rings far off in the background is a small bluish speck. Not a faint star, but a planet. It's Earth. How small we are in the solar system, but how great our reach as we send our cameras far and wide to bring us news from the lords of gravity, our solar system's largest planets. Saturn. To the ancient astronomers, it was the end of the line, the last stop before the stars. It turns out Saturn is merely the farthest planet the human eye can see. It's far, but it's not where the solar system ends. Once the telescope was invented, we discovered there was a lot more to our solar system than meets the eye. There's Uranus, Neptune, and the weird case of a planet that's not really a planet, Pluto. But even through the most powerful telescopes, these worlds remained remote and mysterious. To probe the solar system's real outer limits, you need a spacecraft. In 1977, Voyager 2 began an epic journey that would make space history. To date, it is the only spacecraft to visit planets beyond Saturn, starting with Uranus in 1986. Uranus's most obvious feature is its striking aquamarine color. This is the result of a methane atmosphere. Methane absorbs light from the red part of the spectrum, while blue light is reflected back into space. But while Uranus is unlike any planet closer to the Sun, it is not unique in the solar system. After traveling onward 3 times farther from the Sun than Saturn, Voyager 2 finally reached what is now the farthest known planet, Neptune. As with Uranus, it found a blue world, but one with an atmosphere that seemed more active, with bright white clouds made of ice crystals and dark oval storms. Compared to Jupiter, Uranus and Neptune are small, not nearly large enough to be big balls of liquid hydrogen and helium. On the other hand, they are still far larger than Earth, too large to be solid rocky planets like our own. So, Uranus and Neptune are fluid worlds, but they are mainly made of gases that freeze at low temperature, including water, methane, and ammonia. For this reason, they are called ice giants. Although you don't see any ice when you look at these planets, they must have formed from countless icy fragments that once filled the outer reaches of the solar system. Like Saturn, both Uranus and Neptune are encircled by rings, but their rings are narrow and dark. So dark, in fact, they resemble the color of charcoal and must be rich in carbon. They may be the last remnants of small moons that were disrupted by gravity and pulverized into tiny fragments. The rings are just one element in a story that suggests this quiet and dark outer region of the solar system was once witness to scenes of great violence. Uranus, for example, is nearly tilted on its side. Instead of spinning like a top, it rolls like a bowling ball, first pointing one pole and then the other almost directly at the Sun. Its rings and moons are oriented the same way, giving Uranus the appearance of a giant bullseye in space. This peculiar tilt was almost certainly the result of a giant collision long ago in the planet's history, perhaps near the time it was forming. Other signs of past collisions can be found on Uranus's bizarre icy moon Miranda, which looks like it's been blasted apart and put together again the wrong way. Its craggy cliffs are among the highest in the solar system. Meanwhile, Neptune's largest moon, Triton, orbits Neptune backwards. How this happened is not easily explained, but it is likely Triton did not begin as a moon of Neptune. As Voyager 2 discovered, Triton is only slightly smaller than our own moon and larger than Pluto. It may have once been an independent citizen of the outer solar system that wandered too close to Neptune and was captured, perhaps after colliding with some of Neptune's other moons. Today, Triton's icy surface is crisscrossed with markings that hint at a geologically active past. The surface is made of ice, frozen water, but it's cold enough to be as hard as rock, and has a strange texture resembling the skin of a cantaloupe. Much of its southern hemisphere, the only part seen by Voyager, is covered with a methane and nitrogen frost. Dark streaks on the ice are probably the sooty residue from gas geysers breaking through the icy surface. The streaks are parallel, suggesting that winds blow fast in Triton's thin atmosphere. If Triton was captured by Neptune, then it is our first opportunity to see up close an entirely new class of objects. These are small, icy and moon-like bodies that escaped becoming part of a larger planet when the solar system formed. Now they silently patrol the vast border region of the solar system, starting just beyond the orbit of Neptune and extending far into the deep space beyond, where the distant sun is no more than a bright star. Pluto and its moon Charon are surely members of the same family. When it was first discovered, Pluto was hailed as the ninth planet, but its tiny size and unusual orbit suggest it is not exactly a planet, but something else. In recent years, many more objects have been spotted at a similar distance, including Eris, found in 2003. Eris is even larger than Pluto. Rather than making it the 10th planet and potentially adding many more to the list, astronomers demoted Pluto instead. Now Pluto and Eris are grouped with similar objects in a newly created category, dwarf planet. The region where Pluto, Eris and other dwarf planets live is known as the Kuiper Belt. As many as 70,000 separate objects larger than 100 kilometers may ultimately be found here, and they are clearly not all alike. For example, the Kuiper Belt object known as Sedna is redder than Mars. Its color may be due to chemical changes that occurred during billions of years of cosmic rays striking organic molecules trapped in Sedna's icy surface. Sedna's orbit stretches out far beyond the Kuiper Belt, suggesting other hidden members of the solar system may still be lurking just out of sight. Tiny and remote, the inhabitants of the Kuiper Belt appear as little more than dots, even in the world's most powerful telescopes. Yet these objects are among the most interesting to scientists, because they can tell us a story about the early days of our solar system when the giant planets were still forming out of icy building blocks like these. In 2006, to satisfy our curiosity about these most distant members of the planetary family, NASA launched New Horizons. No spacecraft has ever traveled so far to meet its primary objective, and the journey has only just begun. Now New Horizons is well on its way to the outer limits and is scheduled to reach Pluto in 2015. When it arrives, it will be moving too fast to be captured in orbit. Instead, it will fly past both Pluto and Charon, radioing back images and data and showing us for the first time what a dwarf planet is really like. At its closest, New Horizons will see details as small as 50 meters across on Pluto's icy surface and look for signs of past geologic activity. After Pluto, New Horizons will move on to other targets in the Kuiper Belt, including some which may not have even been discovered yet. If it succeeds, scientists hope the most distant and mysterious region of our solar system will finally seem a little more familiar. When New Horizons finally shows us Pluto, it will mark the end of an era. Pluto is no longer officially called a planet, but it represents the last type of solar system object that we have yet to see up close. Without Pluto, our story of the solar system and its history is missing an important chapter. New Horizons will write that chapter and for the first time give us a glimpse of the entire book, the whole solar system in all its diversity from the blazing sun to the dark depths of the Kuiper Belt. Somewhere in that book is the story not just of rock, gas and ice, but the story of chemical complexity and life itself.